Hmm. Now we want to have the minimum one compared to the jump game one. maybe from index to index we can say free, and the last one 0 to 2, 3 and 4. That's one way. The other way is 0 to 1, and then from there directly to 4. What else? 0 to 1. Yeah, 0 to 1. And then it can do 3 and 4, or it can also do 0 to 1 to 2 to 3 to 4. This is coming from going one step, jumping one step, and this is coming from jumping 2 steps. And you'll just have, this is like has 3, this has 4, so when you compare them you'll return the 1 here. I don't know how to cache it though, because you'll probably, so when you want to cache, you are utilizing the fact that you don't need to calculate something anymore. But here you are still calculating something, I think. So when you touch to an index, you are actually calculating the minimum number of jumps from that index to the target. So maybe you can actually cache it as well. Let's lay out the structure. It will be a dictionary, of course, from what will it represent? What will you remember? It will remember the index that you're in, which is integer, and then it will remember how many jumps there are from that are minimum to reach the last index. So it's also like an integer, right? And it's always guaranteed to reach an index. But maybe not from that index. Yeah, so it can be an integer, or if it can be like something very stupid, so you can make it none as well if it's not able to jump from there, so it can just backtrack. Or just make it so high, right? Just make it so high. We have do we have something for the integer for that? But maybe we can make it, I don't know, it's like length is this one, right? You can make it so big, so let's we can give it a weight that it's like it doesn't make sense to follow that path. We have a recursive function. It will have the index, and it will return an integer which will correspond to the minimum number of jumps from index to last index. Right. The base cases we can pass, right? But let's finish it. So we'll start from the first index, and we'll return whatever that it will return us. But maybe, yeah, I think so, right? If index is actually the last index, we're there, we don't need to do any jumps, right? It's just return 0. If index is in the cache, it's already calculated. Just return the value in the cache. Otherwise, we have to right now create more recursions. Imagine you're at the start here. What do? You can only jump to like either you can jump here or to here, right? So you'll probably do something like for your basically jumping range, right? Let's have it like I in range from 1 to the value that is actually there, which is actually a nums index. We'll come back to this, but what you want to do right now, you'll recurse with that. And then you'll probably calculate the max, right? So let's min jump, or like I don't know, res, let's call it, okay? If it's like a none, or make it a very big integer. I don't remember. Python big integer. I think floats have it, but let's do something like this is the length of the array. So if you make it about this number, all right, let's give it a bit more. Okay, so you'll just recurse and have it, and you'll just probably do the comparison here. Not the max, of course, you will take the minimum one, and in the end you'll check which one makes more sense, right? You'll just cache it there with the result, and you'll return the cache whatever value that you've set up there. So for here, you are iterating from 1 to 2. Starting from 1, you are recursing to the next index, and from there on you call on this again, and you come here. You'll start from 1 to 3. You decided to go take the I as the 1, and you will again call this one, so this path will be taken anyways. But once you reach this 4, you'll say, oh, we're at the end, return 0 here. So the moment that you call it that one, basically you call it here. So you called it here, this one will return 0. So you have to probably take that into account, how big of a jump it was, right? So it will be the cost of from there, and also the jump that you've taken. It's 1 here, right? Just give that one there and take the minimum, you'll go on like this, and then in the end you'll write it there. But so yeah, so here you've you probably had only one option here, right? This way. Actually, wait, you need to also take care of this this size, right? If it's equals to that or bigger than that, that's also a single jump. The problem is like, yeah, anyways, let's I think it should work. It's not. Okay, we need to go one by one. So this we call, so this is being called. We initialize this cache, initialize this dictionary basically, then we read the function definition and then go to here. It will call this one with the index 0. The index is 0, which doesn't enter here, it doesn't enter here because it's not there. The result is basically the minimum number of jumps right now is like very high number, okay? And then we'll just go ahead and have from 1 to 2 for I, so this one will be 1, and it will go to index, so recurse 1 will be called, right? So we recurse 0 is called and the dictionary is empty, and then recurse 1 will be called, dictionary is still empty, right? And then here it will not enter here because 1 is not the latest index, or yeah, basically you're checking if it's still in the bounds of the nums. No, it's not there. You go here for item range this, so now you are going to again call 2 because of here, right? The I is 1 and index was 1, so recurse 2 will be called. Recurse 3 will be called then, and recurse 4 will be called. Here in this case it will identify, okay, length of it was 4, so we match here, it will return 0 immediately. So here we are in the recurse 3 right now. This one returned 0 and I was 1 there, and the minimum will be updated to 1. The rest should be 1 right now. Yeah, so from here on, do you need to check the other things? So it's basically there, it was only wait, oh no, okay, it doesn't enter here. It has to be like this because it's not inclusive, right? The value here. Do I need to change anything else? I don't think so. Yeah. So here from 1 to 1, so if it's like 1, it can jump from only 1, right? It will iterate, enter into this one. So I think now it should work. And it's not. It found it as 4. Okay, so probably here it returned 0, right? And then recurse 3 returned 1 for that, and cache is set to index 3 was 1, and this is cold. So this one is returned 1 here, and with +1 it became 2, and this became 3, and this became 4 here. Wait. It actually should scan still. It shouldn't just, it should have, I don't know. I'm missing something, but let's not optimize right now. We'll see it later on, but this there is something that I'm blind right now. So let's say you come to here, recurse 1, and you, I don't know why, I just want to print it out, man. Yeah. Just print cache, like whatever you have here, whatever you set it up. So it's set up 1, 2, 3, 4. Yeah, I mean at the 4 here, why don't you just give a bit more chance to like here you can actually like do 3 steps and go there, and it will be like 0. This will be 3. 3 plus 0. Oh no. Oh no. Yeah. It doesn't really matter how long you jump. It's just 1 always. It's just 1 jump to go there. The thing here is it will just jump one by one. It will not jump in big amounts. So what you can do here is, instead of going with this direction, you can say, you can reverse it. Like you can start from basically a nums index and you can go until 0 so that your last jump will be at like 1 step, okay? And you can decrement by 1. Will it change anything? I don't think so. This basically, we're just going in another direction, but it doesn't change anything. Or will it? I don't think so. No. It will jump there, and there on it will try to populate it. And if you already find something, do you still need to compare it with the rest of it? Like if during this iteration, if you already find something, I think so, right? Otherwise you can go 1 1 1, it's 3, but you have to take this one into account as well. So I think this is it. Seven seconds of runtime. Yeah. Let me check the comments right now. I have to leave though. Interesting. Extremely slow. Thank you folks. Selamlar. Yayını bitiriyorum. Yeah, I'm ending the stream right now. Just wanted to check the comments. Thank you. The question is 45 jump game 2. You can solve it on Leetcode and check it out. This is probably not the best solution because it's like basically I'm at the end of here, So there's probably a better solution. I just don't want to skip to that right now. Maybe I will allocate a proper time to it. But yeah, thank you and have a nice evening, guys.